Well, thank you all for coming. It's really great to see so much interest in this topic. To have an evening presentation and have this many people in attendance is really fantastic. What I'll be doing today is presenting about forest carbon science and management. As was mentioned earlier, this is to help provide definitions, context, ideas to support people in being able to think about this particular integrated resource project and climate and carbon, as well as to talk about the issue more broadly, because there's a lot of interest as we see tonight in that. The way that we'll do this today is I'm going to be leading up the presentation that Todd and I put together. We work on these topics really closely and have been working in New England, across New England, with a variety of land managers for a number of years. So I'll give the bulk of the presentation. I'll give Todd the option to interrupt me or add on something if I manage to forget in trying to cover all of the things I want to try and cover tonight. I do have probably a good 45 minutes to an hour of presentation. And given the number of people who are in attendance, what we decided to do is we are going to collect all of the questions via chat. You can put them in the chat box to Sean. It says questions at Sean. So if you have any clarifying questions about the content, if you have questions that we'll have at the end, please send those to him and he'll help us moderate those. Then I can focus on giving the presentation. And then when the presentation is over, we'll be able to have more Q&A and hopefully discussion. But we just wanted to do that to be respectful of people's time. Otherwise, we'd never get through the talk today. So that is the plan. I appreciate being here. As Sean and Chris mentioned, Todd and I work for a group along with Maddie called the Northern Institute of Applied Climate Science. And NIACS is a partnership. It's a multi-institutional partnership. It's led by the U.S. Forest Service, but we actually have a variety of university, conservation, research, and tribal partners in this effort. And so we work very closely, being a Forest Service-led institution. We work very closely with the National Forests, with the research station, but we also work across a variety of land ownerships in the Midwest and Northeast US and beyond. And our group was really developed and has evolved over time into being focused on what are called climate services. It's kind of a new field. And the idea here is that ever since we were developed more than 15 years ago, there's this recognition that there's a lot of really fantastic science that is happening related to climate change and carbon and natural ecosystems. And that information, if without action, can sometimes stay with the research organizations and it doesn't necessarily make it out into practice. And so we are a boundary spanning organization designed to help bridge that gap and make information related to carbon and climate more available to the natural resource organizations, federal, state, tribal, conservation organizations, private woodland owners. We work really across the landscape in helping people think about these issues. We have a variety of projects and tasks that we take on. A lot of this involves science translation, trainings to professionals, technical assistance to groups like the Green Mountain National Forest and other land management groups to help people address climate change and carbon in their work. We have scientists who do new scientific research and also synthesize science on a variety of topics related to climate impacts, tree species responses, and carbon. And then we have team members who address climate change, do climate change communication and outreach through the other organization, through a number of organizations as well, including USDA Climate Hubs and Climate Change Resource Center. All right. Let's see here. So what we do, I just need to get my presentation queued up and I'm getting a little clicky. And so really what I'll be approaching with this today is this recognition that when we work with land managers, whether that's National Forest Service or other organizations, we are really thinking about a variety of different values that we get from forests. in terms of, these different benefits that we're trying to get that Chris mentioned. These particular ones on this slide relate to the Green Mountains in particular, in terms of the forest plan. But, this list of considerations is really important no matter who owns or stewards the land, manages the land, because we all want to get multiple benefits out of forests. And the way that we think about this is, how do we add climate change into this list of considerations that we have, so that way we're making sure that we are thinking about climate change in the big picture, and that we're meeting this multiple use mandate that we have. So in terms of today's talk, I'm going to focus primarily on forest carbon. And so really here we're talking about climate change mitigation, forest carbon management, greenhouse gas mitigation. And these are actions that reduce the greenhouse gas emissions that are responsible for climate change, as well as enhance carbon sinks. And so when I talk about forests in this particular context, we're really going to be talking about taking advantage of that ability of vegetation, of plants and trees, to absorb carbon dioxide from the atmosphere. So that way we're reducing the amount of greenhouse gases in the atmosphere that cause climate change. But there's another part of this in terms of thinking about actions that reduce the vulnerability of systems to climate change effects. And so, this is the adaptation side of things. And you'll see throughout this presentation that I'll be bringing both of these in, and increasingly more on the adaptation side as we go through this, because these are really both important. All right, so why is there so much interest in forest carbon? There's been a lot of interest. It's been since the beginning of NIACS, which is more than 15 years ago. It's been growing and growing, but I think we've really seen acceleration in the past few years in recognition of the enormity of the climate change issue, the need to address it. We in the U.S. Department of Agriculture and in the U.S. government are paying a lot more attention, doing a lot more work related to the executive order on the climate crisis. So there are a lot of different activities that are going on in this. And so really thinking about how can we use this idea of natural and working lands to help absorb carbon dioxide from the atmosphere and be part of the solution, along with emissions reduction and renewable technology and all of these other pieces, because we need to bring all of these resources to bear in solving this really challenging issue. So US forests absorb, and this depends on how you count it, but it's sort of in the realm of offset about 12 to 15% of carbon dioxide emissions. And they contain a really large amount of the terrestrial carbon that we have. And so work that was done by the Nature Conservancy, a variety of scientists and others globally and in the US, really bring together this piece of what are natural climate solutions in thinking about how can we get to carbon dioxide mitigation in these natural systems. Here. And so there's a variety of studies. This is something that's evolving very rapidly in terms of the number of studies. And so this particular graph I'm showing is more of a global version. There's a US version, there's state level assessments. Regardless of which particular study you're looking at, the idea here is that when we look at forests, there's kind of three big options in terms of how we can address use forests and natural working forests in particular for natural climate solutions. And so these are reforestation, avoided forest conversion, and natural forest management. So I'm going to describe each one of these broadly and then dive into natural forest management in greater detail. As I do this, I wanted to set up a few parts in terms of definitions. I think forest carbon is just inherently a complex issue. It can be easy to talk past one another because of the words you're using. And so I try, I know it's hard, and I even catch myself sometimes saying the words that I don't intend to, but try and be precise in the terminology here just to make sure that I'm being really clear. So sometimes I'll be presenting some data around storage, carbon storage in forests. And so carbon storage is where carbon is retained in what's called a pool in the forest. So this is live trees, roots and below ground portions of trees, dead wood, soil. There are different places where carbon is stored in the forest or in wood products. And I think the important thing about storage is to think that this is an amount. So it's a mass or a volume. There's kind of an amount of something there. Sequestration is that process of photosynthesis, pulling carbon dioxide out of the atmosphere, where you're removing it, pulling carbon dioxide, taking advantage of that ability of plants to do that. And so sequestration is described as a rate. And so it's, how much carbon is essentially being pulled from the atmosphere in some unit of measure. And so I think this is important because sometimes I'll be presenting a little bit of one, sometimes I'll be presenting the other, and I'll try and be clear in that. As we think about not only how much carbon is stored in forests, but how much is sequestered, how much is absorbed at any particular time, it's really important to put today's presentation in the context of the land use history of Vermont and New England, because it's different across all parts of the country, across all parts of the world. And so we really want to think about what makes sense. How does carbon work in these particular landscapes, given the legacy of land use, of land management that we have, and the ecosystems that we have. And so we can think about the amount of land conversion that happened as a part of European settlement in this region, prior to 1900. And so this figure, which is related to, a lot of the really great work that's come out of Harvard Forest and Wildlands and Woodlands, is really identifying how much forest cover was drastically removed across Vermont and New England associated with clearing land for farming and pasture lands. And so we see really dramatic decreases in forest cover, associated during the 16 through the 1900s, forests kind of reaching a low point about 120 years ago in the case of Vermont, and then with agricultural agricultural abandonment, forest regrowth restarting. And so we've had forests growing back throughout the 20th century, up until kind of the late 1900s, where we had more land use impacts kind of coming into forest loss again. And so I think when we think about the condition of our forests, the influence of humans on land use, on forest history, is really hard to pull apart, particularly in New England context, because there's been so much use of the forest associated with European settlement over time. And as I mentioned, we had this forest regrowth during the early to mid 1900s, but we're also facing land use change again in some parts of New England, more so, the farther south you go, the more you are towards populated areas. But land conversion, land use change from forest to non-forest conditions is really important, because forests and other natural ecosystems, wetlands, I think wetlands are the big ones because of all of the forests, of all of the carbon in soils. Natural ecosystems tend to store more carbon than developed lands. So when we convert those lands from natural ecosystems to development, homes, yards, other places, we really lose the ability of those forests to sequester carbon into the future. And those can be really, those impacts can be really hard to reverse. And so I think this is an important one, and I wanted to call attention to it, not because it matters for necessarily for, it doesn't relate to the national forest lands, because those lands are in forest use as outlined by the forest plan, but because when we look at the sort of the scale of carbon across New England and the story there, it does matter, and we can really think about forest conversion as one way to help protect carbon, as well as all of the ecosystem benefits that ecosystems provide. if you, I'll put it up in a minute again, but if in that figure that I showed where it was kind of those three different ways that forests contribute to natural climate solutions, one of them was avoided deforestation. That's pretty significant in New England, particularly in some areas and on private lands. Another option that's very large at a global and national level, although maybe less so at a regional level, is this reforestation. So as we saw in the land use change, a lot of the forests have been coming back. A lot of land has already reverted back to forests. We have a heavily forested state in Vermont. And so there aren't maybe as many opportunities for reforestation in terms of conversion of non-forest land to forest land as there maybe are in other states. But there still are opportunities to bring trees into systems and help enhance the amount of carbon that is stored in forests. And so, thinking about about reforestation or adding trees to pasture lands, to urban open spaces, and really helping to also reduce the urban heat island. Floodplains, streamside buffers, which can really also be important for agricultural health, the health of water and other resources in agricultural settings, and biological corridors, so connecting forest patches. So there are definite opportunities for reforestation. Again, not so much related to this particular project, but I wanted to call attention to these as being options in the broader portfolio of actions that are available across Vermont and in New England, and something you may even be interested in your own forests or maybe conserved lands that you work with. All right, so then we think about this idea, and where I'm going to spend the rest of the time today is talking about natural forest management and what is the interaction of both passive and active management in terms of some of the carbon implications. And so, like I said, there's kind of this particular figure has, it's global data, it has natural forest management as being, kind of one of the big three options. But I really want to highlight that this is an immense area of study. There's a lot of information going into this. And so depending on a particular study, there's, we could include how do I say this? The size of the bar could really vary depending on how we count things. And I think there's a lot more research that is needed at all sorts of levels. So we don't know the exact amount, but it is definitely something that's worth talking about in the context of this particular project. So maybe I should have had this up a little bit earlier, but I wanted to just highlight kind of where is the forest carbon cycle. And so these are the different pools that I described in terms of where carbon is stored. Carbon storage would be could occur in any one of these boxes. This is obviously a very simplified graphic, but we can think of storage as being the boxes. And then, the sequestration or there's transfers between these pools overall. And sort of sequestration makes up the difference between what's going into any one pool in the atmosphere. So I'm primarily going to focus on the forest component to the forest carbon cycle. I think partly that's because the harvested wood and wood products parts gets very complicated very quickly. There's a lot of assumptions that go into it, and we could have a very lively discussion about how we account for forest carbon in harvested wood products, wood energy. So I think partly it's because it's complicated. I think partly it's because forest ecologist by background, but I think also, in terms of when we're thinking about land management, we have much more control on how we influence the forest itself. And a lot of those other things in terms of the wood economy are outside of the control as we have as managers. We might be able to control how much wood is cut. We might be able to control what kinds, what species, what sizes. But beyond that, there's not a lot that a land owner or manager can really do to influence it. It's more of a system-wide component. So for today's conversation, I'm largely going to focus on what happens in the forest, but I think that is There's plenty going on there to talk about. One other piece that I'm going to say, and then I'm going to dive in, I promise, is to really just, I acknowledge that scale is a very challenging issue in terms of, is a really important issue to consider in terms of how we measure forest carbon. And also just in terms of how we think about biodiversity, how we think about all sorts of ecosystem services. There's a lot of differences in terms of kind of what happens at a stand level, which is maybe a management unit, or is maybe, you know, kind of an area that's maybe a little bit contiguous or recognizable as one block of forest, versus an ownership or a larger parcel or a project area in this particular case, versus a landscape, which can be, you know, a large ownership like the National Forest or the state lands, or the statewide. And so a lot of times when we're talking about forest carbon, it's really easy to zero in, or there's a desire to sometimes want to zero in on what's going on in a particular stand, because that's kind of the human scale to how we relate to forest carbon. You know, we can stand in a forest stand and we can look around the trees and really connect with these places. And I think that's, again, it's the human scale. It's what we're used to thinking about. When there's a harvest, so the carbon might accumulate when there's a harvest in a stand level, that can make a very big impact, because you might see the difference, you know, in a short period of time in one particular area. But as we zoom out and accumulate multiple stands across a larger property or a landscape, the impact of one individual stand, you know, becomes less because we have it averaged out over a larger area. That's not to say that what we do at the stand level doesn't matter, but I think sometimes, you know, we need to also kind of be able to kind of, you know, like Nancy Patch calls it, like the cosmic zoom. Like we have to be able to kind of zoom out sometimes and look at things, and then zoom in and kind of recognize when we're changing that scale and thinking about these issues. Okay. All right. So I want to first do that zoom out and talk about forest carbon at a really broad level. So I'm going to talk about Vermont first. This is from recent work done by the Agency of Natural Resources to produce a carbon assessment. This is using Forest Service inventory and analysis data, largely other data sets. And so on the left, the figure here is storage. So this is how much carbon is stored in forests. Well, it's really related to acres, but how much, you know, kind of acreage of forest is there across Vermont over time, you know, the last 10, 20 years or so. And so we can see kind of that pattern that forests acreage has been relatively steady, but there's been some decreases in terms of loss over time. But this is pretty similar to what we see trends across, you know, again, most of those New England states. Is a steady, maybe some decrease in forest carbon acreage, and hence carbon. I'm sorry about that being a little confusing. So on the right, what this is forest sequestration. So remember, this is the rate. This is how much carbon is being pulled out of the atmosphere or emitted to the atmosphere, the interaction between forests in Vermont and the atmosphere. So if the number is, if it's below the 0 line, so we have black line here being 0, if it's below, that means that the forests are absorbing it. It's being pulled into forests. And if it's above the line, that represents an emission of carbon into the atmosphere. And so we see forests are absorbing carbon from the atmosphere. Settlement trees refers to areas that are settled. So this would be, you know, urban or community forests, trees in developed or community areas. 2 forests represents land that is converting from another land use to forest land. So this would be agricultural lands or that are maybe succeeding to forests over time. Other land use transfers to forests. From forest means it's going from forest to another land use. And so that is where we see that emissions, and that's associated with that land use change. So that's, you know, essentially deforestation, because you're going from forest to another type of land use, and that's removing the carbon from those forests. And then the net flux is when you add them all together. So when you kind of add those three greens and then you subtract the blue, that's what you get in the gray. So overall, Vermont's forests at a statewide level are absorbing carbon dioxide from the atmosphere. Again, this is forest carbon. Where is that carbon stored? Here's this graphic on the right is showing the total amount of carbon stored in forests in Vermont in green. So that big block there, and then just acknowledging that when you do this high level carbon accounting for states, they're able to identify that there's also wood that is stored in hardwood products that are in landfills, because once things go to landfills, they decompose slowly, often as methane, but there's hardwood products stored in landfills and in use. So that'd be things like furniture, paper, items on the left. So you can see the overall carbon budget in Vermont. Okay. All right, so then on this figure, what I'm pulling now from is a forest carbon assessment that was done on the Green Mountain National Forest. So this is using also a lot of forest inventory and analysis data from the forest, from the US Forest Service. And the left side, again, is storage. So this is how much carbon is stored, has been stored kind of over time in the forest across all the national forest lands. Administratively, the Finger Lakes National Forest is also in this data, but it's a pretty small amount. And we can see that forest carbon storage has been increasing over time, largely because of that forest regrowth. Forests are still recovering from, basically coming back to forest lands, coming back online as forests within the last 120 years or so. On the right side is the sequestration rates. For both of these figures, that green shaded area is actually the 95th percent confidence interval. And so what we see on the sequestration side is that the forests are generally the Green Mountain National Forest is pretty close to zero, which means it's generally it's generally relatively even in terms of how much carbon dioxide it's absorbing from the atmosphere versus releasing. The fact that it's slightly negative over the last 10 or so years of this diagram suggests that it is a slight carbon sink. It's absorbing carbon slightly, but I will acknowledge that there's pretty wide error bars on this associated with the number of inventory plots that are available. All right. And yeah, these are data through 2013. Where is carbon stored on the Green Mountain National Forest? And we have the Finger Lakes in here too, but it's only a small amount. These are the different types of pools for forests. You can see that not the majority, the largest block in this particular figure is above ground live trees. So this is, I think, the part of carbon that we're most, I would say this is maybe the part of forests that many people are most used to thinking about. If you ask a kid to draw a picture of a forest, they're probably going to draw the live tree portion of the forest. But it's also really important to recognize these other places where carbon is stored. So we have soil being a tremendous amount of carbon being stored in the soils. It can be more than half of the carbon can be stored in soils in some forest types and wetlands. So it's really important. These values here are just in the top meter. If we start to dig deeper and measure all the carbon, there's even more in the soil. The forest floor, so the litter layer, the below ground live trees, so roots and everything below ground, and then standing dead and understory. So this is, every forest is going to be a little bit different, but this is when they're all put together what that looks like. All right. It's funny, I haven't been able to pay much attention to the chat. I'm rolling through my slides. We'll have plenty of time for Q&A, but I want to make sure we get through the presentation. And so I haven't been looking at it, except I saw someone literally just typed in this question to me. So I'm glad I am on point. So I'm going to roll through a couple questions in terms of now, how do we think about carbon, forest carbon in terms of management activities and as well as climate change. All right, so first, do older forests store more carbon? Just to kind of provide a little bit of background, I wanted to explain kind of how forests develop over time, because I think this helps set up this idea of stand development helps us understand where carbon is. So I'm mainly going to be describing things in terms of a lot of above ground forest carbon, because again, that's sort of the part that we see, but all of the information that I provide and we'll be talking about incorporates all of those different forest carbon pools. So as I mentioned, a lot of the forests that we have today were cleared at some point as a result of agricultural past land use. And so not all of them, but a lot of times when we do this in the simplified representation, we start with stand initiation. So you kind of start from no trees, maybe 120 years ago. You can think about sheep farm, stops being a sheep farm, stand initiation. Then what happens is we have the small trees come up, they get to a certain stage, and you guys have seen this, where all of a sudden they're tall and skinny and they're all competing for space. And it's a stem exclusion. So they actually kind of start out competing each other. So the number of trees decreases as the size of the trees increase. Over time, as that development happens, the trees are able to kind of start to develop a little bit more structure to the forest canopy. Some are starting to outcompete others. That's creating more light to hit the forest floor. So we get the stand initiation, so that undergrowth is able to come up in terms of being able to kind of start thinking about baby trees coming back in. And then again, then we have maybe more canopy disturbance. Some trees will fall down, we'll have more trees coming in, and we start to develop kind of what we might consider, it takes a long time, but towards this old growth stage. But really what I would call it is a multiple stories, where you have kind of multiple, you have that structural diversity of multiple levels of canopy and multiple ages of trees over time. And so this is a very simplified representation, but I think it can help kind of set this point of, this is how we would see stands develop over a very long time, where they had been disturbed at the beginning. So I think one thing to talk about with old forest is to just, I think first is to set up some definitions, especially when it comes to some of the national forest documents. Old does not necessarily mean old growth. And so I'm going to be talking about kind of forest age and development, and not necessarily old growth. Old growth is often considered, I'll talk a little bit more about it. Simplistically, we can think about it, often it's called primary forest. So it would be forests that hadn't been cut over at some point, maybe 100 to 200 years ago, primary forests, certainly, but, we can think about that. A lot of the forests that are called old, when we look at some of the planning documents for the National Forest here, and I think often when we talk about older forests, we have to acknowledge that they are what's called secondary forests. They're originating from post disturbance, there's a land use change in terms of agriculture, like I said, at some point. And so I think the pathways and the way that we think about carbon in each of these systems is it's important that we be distinguished when we're talking about one versus the other, because there are different assumptions or kind of different pathways associated with each. The old also varies a lot with forest type. So aspen, which is an early successional forest type, is considered old at 60 years. But northern hardwoods, it's 120 years. And so again, we really have to be thinking about kind of old in the context of that stand development for that particular forest type. Disturbance dependent forest types like aspen and birch don't become old in the same way, because these are kind of early successional forest types that will over time likely transition to a more variety of longer lived species like maple and birch. And age can be hard to describe in terms of multi-age stands. So if we're starting to move stands towards those later successional pathways, towards kind of this multi-age, multi-storied structure, the idea of age starts to kind of fall apart, because you might have some trees that are very old and you may have some trees that are relatively young. A lot of caveats, had to get them out there. I apologize, but I think it's important in terms of the conversation. So on the right here, we can see the stand age distribution for the National Forest. It's very similar for Vermont in terms of, yes, I'm going to show it on Vermont on the next slide. That's why I got confused for a second. So we can see kind of how the age is distributed, how old different stands are for different forest types on the National Forest lands. You can see that we really do have the vast majority of those age classes really coming from that duration that I mentioned, that reversion of land about 120 years ago and since in the 1900s, really. And when we think about where that is in terms of stand development, again, mileage varies by different forest types, but when we're talking about maple beech birch or northern hardwoods, which is the dominant forest type on the Green Mountains and also in the particular project area, we're looking at a lot of stands that are in the stem exclusion to understory reinitiation phase. And this is just the amount of time that it takes in terms of forest stands to recover. And again, not all of them, but a lot. And we can see that there's older stands out here on the right. All right. All right. So, so when we think about older forests, and again, I'm talking about stand development, not necessarily a particular age, what we see is carbon storage generally increases over time while the rate of accumulation slows. And this makes sense because when trees are in that first kind of stand development stage, they're just free. It's called free to grow. There's all the sun, all the space, and they're just trying to shoot up as fast as they can in terms of growing. And then as they start to compete, and the rate of growth will kind of slow a little bit. And so we see that over time. So older forests tend to have greater storage. There's more carbon per acre. The sequestration rates are relatively lower. Now, old forests can continue to sequester carbon for a long time. So it's not that it stops necessarily. I think that's changed in terms of how forest ecology has evolved over the last 50 years and how we see old forests. But generally the rate will slow. Because there's just a lot more energy put into maintaining the current plant tissues. There's mortality, there's different things going on. Younger forests don't have a lot of carbon in them inherently, because especially above ground, the trees are relatively small. They haven't developed yet, but they tend to have higher sequestration rates because of growth over time. So we can kind of see on the figure on the right, bottom right, what happens. This is volume of trees. It's just how we measure trees. Different forest types, what we can see is as the trees are at these young ages, 10, 20 to 50 years, we see this really fast rate of carbon accumulation. Then it levels off over time. All right. So when does it start to slow? Yeah, what happens? So we have a lot of data in these middle-aged stands because they're the most common. But what happens when we get to the old side of this figure and it's kind of empty and it's unsatisfying? So there are fewer data points here because there's less old forests. We have to go out and find them and measure them, and we don't always know where they are or what to look for. There isn't a particular age at which I can say that a forest is going to slow. It's going to vary by stand. It's going to vary at all those different scales. And it's going to vary by forest type. So I think one good example here is if we look at this blue line for aspen birch, those are early successional forests. They grow really rapidly and it levels off sooner. That rate levels off sooner than if we're looking at something like northern hardwoods, this green line. That's a slower type of forest to develop. So that curve, if we were kind of to extend it into the blank space, is probably going to continue gradually going up for much longer. So it's based on the forest type. I think the site in which the forests are growing is going to make it's going to be important. So we'll have carbon gains likely in, if the trees are healthy, if they are long-lived species, if we have high quality sites that have nutrients, have the right amount of moisture, and there's a lack of disturbance to affect that stand, we will tend to see more of a leveling, no change, or maybe even losses over time, kind of forests kind of declining, where we see poor quality sites, stress, disturbance, or any sort of instance where tree mortality exceeds growth. So that could be a pest outbreak or a really severe windstorm, something like that. All right, let's see here. All right, so do older forests store more carbon? It's trying to figure out how to summarize my feelings on all of these. So I'm giving you emojis because it's late at night and that might be all I have left. And I'm realizing we have a lot to get through yet. So generally, yes, older forests are going to store more carbon. It's part of natural stand development. The big caveat or kind of big piece here is in the absence of disturbance or severe disturbance, like because that's going to disrupt the ability of forests to store carbon in all of those different pools. The rate of carbon accumulation generally slows with age. This doesn't mean it stops, and I know big trees continue to absorb a lot of carbon, but they take up a lot of space as well. So, I think that's an important part of it. So there, and the forest type influences the patterns of storage and sequestration. Different forest types have different potential. They have different life history traits that are going to take different durations, different times to develop. The site conditions are going to matter. Any sort of land use legacy is also going to influence the ability of a forest to develop and store carbon. All right. Let's see here. All right. Do older forests have biodiversity benefits? Like, I'm not talking about biodiversity today, but I wanted to give this one a big heart eyes because old forests are really fantastic for a variety of other benefits. There's really good work that shows that as we develop, stands can develop into later ages. They can also, later, let me think of how to word this. Older forests can also tend to have a lot of other benefits for biodiversity associated with them. Those two characteristics do correlate well for a lot of reasons. Other ages matter too, so I think we have to zoom out with that landscape perspective and remember that at a landscape level of diversity, we need to make sure that we have a variety of forest types. Having differences in forest age is important, but older forests can have really great biodiversity benefits. This is coming from a lot of what we would call late successional characteristics. And so that can be in a managed or an unmanaged context. And I'll talk about that a little bit more later on. But really, it's not just that the forests are older, but it's that they've had the potential to develop complex stand structures, accumulate dead woody material, have an abundance of large old trees, and get to these later kind of stages. And all of this boils down to, a lot of times it's about complexity, both at a stand level and a landscape level as well. And older forests can help contribute to that complexity. Okay, does allowing forests to age increase the resilience to climate change? I think this is the other piece, right? I talked about mitigation, but what about adaptation? If we allow forests to age, does that help enable them to cope with climate change as well? Just to describe resilience, there's a lot of ways to describe it, but it's really this ability of an ecosystem to accommodate a bit of change or disruption, but to be able to recover to a similar condition after disturbance. So it's this bounce back ability. There's lots of models and they talk about cups and balls in a cup. You can imagine if I have I'm not going to hold it because I'd make it switch, but my, coffee cup and I get bumped, am I going to be able to keep it inside my cup and not spill it all over my keyboard? It's that ability of a system to kind of bounce back and not be disrupted or change state is what we talk about for resilience. Okay, so how does forest sort of age and development relate to climate change? I think climate change is a major disruptor. And so we need to think about how a changing climate poses risks to forests and the carbon they sequester. The Department of Defense calls climate change a threat multiplier. And so we have all of these impacts we're expecting to see across the are seeing and are expecting to continue seeing, whether it's warmer precipitation, changes in warmer temperatures, changes in precipitation, more extreme weather, more extreme rain, and all sorts of stress and disturbance. So we really need to think about how does climate affect forests, and then how does that affect carbon? Okay. So many northern tree species and the forests are vulnerable to climate change during this century. Some of the work that I've done with a bunch of different scientists and managers from across the region was to develop a vulnerability assessment looking at how forests are affected by climate change. There are a number of other forest vulnerability assessments that have been developed for Vermont, for other states, for the regions. What they all really point to is that a lot of the northern species and systems that we think about, so high elevation and more northerly systems, are more vulnerable to climate change because those forest species have traits where they are adapted to cold climate. And as the climate becomes warmer, they become more stressed, they become less competitive. And a lot of our forest communities are composed of species that may be vulnerable to climate change. And so we really need to be thinking about how is climate change going to affect these different ecosystems over time. And so I think one of the pieces in this is that when we look at some of, I'm just picking the study because I know a lot of people, reference it. If we're looking at how do we let forests grow over time, a lot of times this no management line in this particular study and others, there's kind of this assumption that if we let forests grow, they're going to continue growing much farther into the future, that we're going to continue that recovery over time as we always have. But what's missing in a lot of these analyses is that they don't incorporate future changes in climate, whether that's temperature, disturbance, other stressors. There is not disturbance included, and there's not just natural disturbance that happens on the landscape, but then they're not thinking about the enhanced frequency or intensity that climate change brings to a variety of forest disturbances. And that those things can also cause growth declines because there's more stress on trees. So I think it's important that we recognize that although forests would normally be able to continue growing and absorbing carbon and building up those stores in the absence of climate change, climate change is a game changer. And so we have to think about what's going to happen to trees where we're incorporating those impacts. So in Vermont and New England, there is just a wealth of modeling studies that have looked at how climate change will affect different tree species, different forest species. I'm putting slides. My slides show one study, but there are way more than I've listed here. They're all really fantastic. And what we tend to see when we look at different studies that model how tree species, how forests may respond to climate change, what we see is there tends to be growth to some point into the future. Maybe it's 10 years, maybe it's 50 years, but by about mid-century, we start to see where climate change has a stronger influence, but then also just forest aging. And so we start to see declines projected for a lot of tree species. And those declines are often greater under scenarios of more warming. So we can think about, a tree species like sugar maple. It's, really dominant on the landscape. It's doing really well. In the near term, it will continue to do well as forests recover from this past disturbance, as the trees get older, because they can have the capacity to grow really old. They may be benefited by slightly warmer conditions, but then as we get farther into the century, the climate change becomes more severe. And so we have the potential for declines for these tree species over the long term. And that doesn't mean that all of the tree species all of these trees are doomed, but it does mean that they will be under greater stress, and particularly in sites that are less suitable. Okay, does allowing forests to age increase resilience to climate change? I'm going to talk about this a little bit more, but at least as far as taking a pause right here, it's not this shrug emoji is not an I don't know, but it's more of a it depends. And I think, again, it's really related to that risk of future forest decline or disturbance. And so if we're in an area, in a forest that has low vulnerability, a place where we don't think climate change pressures are going to be as strong, maybe it has high adaptive capacity because it's a really healthy forest system, it's probably has a better chance of continuing to store and sequester carbon over the long run. But we also have to include, this idea that climate change increases risks to forests and the carbon they sequester. So in terms of, where to focus our efforts, we might want to think about areas that already have a high carbon density and kind of playing some defense to try and maintain those carbon stocks, protect those forests, as well as forests that have, again, lower vulnerability might be places where we want to emphasize. But these are just a few priorities, and I'll talk about this more in a second. All right, you guys are great for sticking with me. We got a little bit of not even a late start, but there's just a lot to cover. So I appreciate this, and I see questions rolling in. I'm sure that Sean has plenty too. Okay. So then we've talked about carbon a little bit in terms of forest development. We've talked about climate change generally in terms of providing, potentially creating more risks. That section I just talked about, I would like to make into like a 4-hour presentation because I could talk about it and think about it quite a bit more. It's really interesting. So here I want to think about what actions can reduce climate risks to forests while providing benefits for carbon and other ecosystem services. So how do we bring, that climate adaptation and carbon mitigation together? Okay, there's no single answer. And I think this is the part where, when we think about managing forests, there's not a single answer because we really need to be thinking about, just like you do with other things, risk hedging and being able to think about long term, is we need to have a portfolio of options. There's not always going to be a single answer that we can prescribe across a landscape for a particular landowner or for a particular forest type. And so we really need to think about what makes sense in a particular place. To do this, Todd Unsel and led a team of us to develop what's called a menu of actions. And this one in particular is looking at actions to reduce, we call the forest carbon menu, actions to reduce carbon losses through climate adaptation and identify areas where we can encourage carbon gains through climate smart forestry. And so again, it's trying to think about where can we find the areas that these two things overlap so that we can get multiple benefits, that we can have our carbon be resistant to change and resilient over the long term, given the pressures that we are anticipating from climate change. There's more than 200 peer-reviewed papers and reports, and we have tested this with real-world projects. The menu contains a list of strategies. It has approaches that describe the strategies and more ideas, and more specific actions as well, example actions. What I want to emphasize is we call these menus because it's this idea that there isn't a single answer. You pick and choose what makes sense based on your particular goals and objectives. And yeah, you're going to decide what makes sense. It's not a checklist. We don't do all of them. They're actually things that are mutually exclusive. And that's okay. We work with managers in that technical assistance that we provide, a lot of times we work with managers to use the carbon menu, other menus through an adaptation workbook process. And this is something that we do with the National Forest as well, and helps us think about what are the climate change impacts for a particular area. How do we think about the challenges and opportunities associated with climate change on different natural resource topics, and then what actions are available. And so this is something I talk about a lot, but I'm not going to talk about too much today. I want to provide an example, though, of a time that we use the adaptation workbook with from another example from Vermont, and this is with the silviculture and with birds in mind, programming that's been developed with Vermont Audubon. And so this is also described in that paper that Todd led. And so if you're familiar with silviculture with birds in mind, or forestry for the birds program, the idea here is to help private woodland owners integrate goals for timber and forest interior songbirds into private woodlands management. And the idea here is that birds represent a variety of forest habitat conditions, habitat features. We've lost a lot of these habitat conditions over time because our forests are more simple as a result of that change that has happened over the last 120 or so years. And so we can use these birds and their habitats as and increase the habitat for these birds to promote a wider diversity of conditions across the landscape. What we did is we used the adaptation workbook with staff from Vermont Audubon and partners in updating, looking at their forest stewardship plan for the Green Mountain Audubon Center. This is an important bird area. It's a demonstration site for foresters for the birds, and they do a variety of topics, activities at this site. And it has sites that are fairly representative of Vermont forests in that they are even age. They all came back from some of that disturbance 100 or so years ago, but they are starting to develop other strata or layers. All right. So their goals, again, we really try and figure out what the actions are help the managers decide what actions make sense for their particular goals. They're looking at songbird breeding habitat, saw timber quality and quantity, increasing that understory, because the understory is where a lot of the birds forage and nest, increasing regeneration by tamping down beach competition, and controlling invasive plant species. And so I think a lot of people like this program and the work that Audubon Vermont is doing, because it represents a lot of private land ownership and public land ownership across the state of Vermont. We talked with them about climate impacts, and so some of those that they were concerned about was reduced snowpack, increase in pests and pathogens, and the increased frequency and intensity of extreme weather, because that can cause problems with soil erosion, water quality, and introduce non-native pests. All right, let's see here. So the idea was, what is the overlap of these particular goals? Can we find that space in the middle and accomplish all three? And so when we looked with them through their forest stewardship plans, we identified a variety of the actions that they had in their forest stewardship plan that they had implemented or were implementing through their active forest management, through their forest management, that they had bird habitat benefits, adaptation benefits, and mitigation benefits. So just briefly, one of the things was identifying no harvest reserve areas within their property. And I guess all of their property is maintained as forest, but they had no harvest reserve areas. So they were allowing areas for trees, forests to develop more, to increase habitat for birds, get those large trees, snags, deadwood, all of those late successional characteristics that I described. This goal would help kind of support landscape connectivity, and from the carbon's perspective, have allowed trees to have all those carbon benefits available to those later successional older stands. They have forest harvest as well, planned in some areas. They use group selection, gaps, a variety of silvicultural techniques. They do a lot of retention, so retaining deadwood, retaining snags, and features for wildlife. So this has bird habitat benefits because that's the goal of their program. But from an adaptation perspective, it also can increase resiliency by reducing the threats to the stand, stemmed, multi-aged, more diverse stands can be more resilient to wind and other disturbances. It can increase species diversity. And then, can help improve the growth of the remaining stands for carbon. And then they're looking at planting or promoting red oak in some of these harvested areas as well. So this is a really quick example, and you can read more about it on our website or through the paper or talk with them about it. This was like a more of a qualitative comparison that we have done with them, but then it worked out that Bill Keaton and his lab also have done some research where they looked at the quantitative side of things, and they published a study looking at the different forestry techniques that were being used with the silviculture and with birds in mind work in Vermont. And really what they did is they compared stands that had recently been harvested using the silviculture with birds in mind approach to not unharvested controls. And they were looking at what are the performance for a variety of different variables in relationship kind of these different treatments. So I know this figure is a little hard to follow, and especially late at night, but I think the main idea here is to point out that there were benefits in terms of the control had maybe the highest carbon storage, maybe the highest H index as a diversity index. It had a high amount of large trees, but some of the forest management practices were able to have fairly high performance as well for these characteristics. In addition to potentially providing other values like the bird habitat being something that they were trying to achieve, or landscape level diversity goals, maybe goals for timber harvest, which is one of their focal areas. And so I think there's a good opportunity here to look at different forestry techniques and see what are the different co-benefits associated with them. I think one I'll just point out, briefly is, the one that's layered on top in terms of the shelterwood with reserves is a treatment that tends to remove more forests, remove more trees, remove more volume. In terms of a silvicultural approach, it's used a lot of times to get those earlier successional characteristics to promote shade intolerant species that need a lot of light. And a lot of times those species are expected to be more future adapted to climate change. And so we can see that increased sapling diversity more than some of the other treatments. So there's trade-offs here in terms of different values. And we, you as a landowner or, everyone could say, maybe there should be other things that we should be using to evaluate these stands across. But I think it just gets back to that idea that we manage stands for a variety of values as well. All right, so what actions can reduce climate risks while providing benefits for carbon and other ecosystem services? And so here is to think about a toolbox approach. There's not a single answer, and it's going to depend a lot on the landscape in terms of where you are working and what you are trying to achieve. And this idea of spreading your risk, of diversifying your portfolio, given the uncertainties of climate change, can help to address site level risks while promoting diverse benefits across landscapes. All right. I know I threw a lot at you. You guys have been great. I've been watching for some of the folks on video to see that you're still awake, you're still around. So just wanted to summarize, and then I'll kick it to Sean to see kind of what some questions came in, and we'll go from there in terms of where we are on time. So thanks for sticking with us. Forests have an important role in the carbon cycle and in removing CO2 from the atmosphere. Certainly, this is something that is not this is certainly something we all recognize. In terms of the Forest Service, we manage National Forest System lands to optimize a wide range of ecosystem services. And that can include carbon, but it also has to include a wide array of other ecosystem services, and it often in the same stand. And so it really becomes an issue about optimizing many benefits rather than maximizing a single one. The Forest Service did develop some carbon principles in terms of how we approach thinking about carbon. And so I think it's good in terms of, again, that idea of zooming out a little bit. really focusing on emphasizing ecosystem function and resilience, given how many stressors forests are facing, recognizing carbon as one of many ecosystem services, which I already mentioned. In terms of considering dynamics and scale in regard to decision making, so trying to make sure that for whatever decision that we're working at, we're making an analysis and a decision that's consistent with that scale of where we're making the decision, supporting a diversity of approaches, and using the best available science. All right. I'm gonna pause, take a drink, and I'm gonna see, I know Sean has been tracking some of the questions. So first I'm going to let Sean direct some of the questions in terms of anything that's a clarification, maybe grouping some bigger themes. We'll do that first, and then, I think if we have time, we'll open it up.
Thanks, Maria. Yeah, there are several questions. And I think the best way might be to go through and just I'll read off the question, and whether it's you or Todd or anyone else, foresters like Chris or James can maybe address them as they see fit. And then as I go through, because there are some questions that are sort of very similar. So I'll just kind of skip ahead to the next one. What's that? So for the first question, let's go ahead and read it here. It says, I'm aware that Telephone Gap has a very significant amount of old and mature forest areas. Are you aware of the growing body of current scientific research that indicates it's vitally important to preserve old and maturing intact forests? Little to no human intervention for their important carbon absorption function, helping to mitigate the current climate emergency.
Ray, do you want to take a break from talking and
I feel like I gave that a good try. So maybe if you want to hit on one or two while I'm catching my breath, that'd be great.
Yeah, it is something you did sort of mention the older forests, but yeah, if you want to just quickly.
Yeah, so certainly, there are, as Maria very adeptly described, the definition of older is sort of relative to the forest type that you're talking about, as well as, just recognizing that the land use history of the region is such that, the vast majority of the forests in the region are, probably not going to be much older than, sort of when land use was reverted back from agriculture back to forests, kind of in the early part of the 20th century. But yes, as Maria also described, those older forests are very good at storing carbon. Now the question, of course, remains, and there's a very robust discussion in the scientific literature about, the ability of older forests to continue sequestering carbon, and the ability of those forests to hold on to the carbon that they already have sequestered in the past, those carbon stocks. And, both of those two ideas are very important here, because when we think about mitigating climate change, when we think about carbon, what really matters is what the atmosphere sees, right? Any action that we take or anything that happens in a forest, what really matters is whether or not CO2 concentrations in the atmosphere go up or they go down. And so it's really kind of, there's those two important pieces, sequestration. So are those forests continuing to absorb additional carbon?
Oh, looks like we lost Todd.
We did. Oh no. That's usually, well, I guess I don't know where he's
Okay.
at today, his internet. We'll let him come back on that.
For us to
Yep.
continue
Okay.
holding on to those, holding on to the carbon? Was there,
Yeah, we had a little bit of a delay, or we lost you for a bit, Todd.
Yeah, that last 20 seconds or so, you kind of froze up and we couldn't hear you, but. Is he frozen again? Okay.
All right.
Well, I'll just go ahead and move on to the next
Yeah.
question. I think it's one I can address. So I regret that you picked one of the busiest holiday weekends of the year in Vermont to do the field trip. Many people will not be able to attend. And, you know, it is sort of unfortunate it landed on a holiday weekend. But as mentioned, you know, when I was introducing both Maria and Todd, that they are, you know, gracious enough to do this for us. They're not Forest Service employees. They're not Green Mountain National Forest employees. And in Todd's case, who's really working on the field trip, he doesn't even live in Vermont. So we really had to work around his schedule. And that's when, you know, he was available. So, so yeah, we realized, you know, there's no way we can accommodate everyone. As you can see, there's over 150 people on this call and many more that received the information for this. So, so yeah, I mean, it really came down to when people were available for the trip.
Yeah, you know, to the other thing, how do I say this? So I guess first, just clarify, I am a Forest Service employee, but
Okay,
I don't work
yeah.
for the National Forest. So just checking there. But people came and score at home. I will say though, you know, the focus for the field tour too is, you know, this particular project area, but to the extent that this is a topic that people are interested in, you know, I will note that I'll also be talking with the National Forest people, and if, you know, there's just general interest and appetite, we may be able to work with some of our partners to provide, you know, other avenues, you know, and probably have to be, you know, next spring or something when the weather is decent, but there may be other opportunities as well. So I'm taking note of that.
Okay, thanks.
sorry for dropping off there. My internet connection was not stable, but I am back.
Okay, did you want to finish up? Did you have a final point on that last question before we froze up, or do you just want us to move ahead?
Yeah, I guess the final point I just wanted to emphasize was that, you know, it's really a matter of understanding kind of what those climate risks are as to the value of kind of leaving forests alone to maintain the carbon that's stored there, and the role of active management to address forest health issues is a very important consideration. And, you know, as we've already heard multiple times, that really it depends. So there is no one single answer. And it really is going to be dependent upon, you know, the information of a particular stand in a particular location as to whether or not to what the best strategy might be from that particular perspective of carbon. And of course, then there's the balance of understanding that there's multiple benefits that we look to our forests to provide for us in addition to carbon.
Okay, thanks, Todd.
John, that one thing I might add on to that is just some context from some of the previous public meetings that we've held. The Telephone Gap landscape is about 32,000 acres. And of that, about a third, over 30%, is in a management allocation. That's what we call it in our forest plan, where management is essentially precluded. And so those lands are going to continue to grow. At least a third of the whole landscape is already set in our management plan on a trajectory to grow into an older age in perpetuity. So I think it's important to realize that we do our management plan, our forest plan recognizes the value of those older forests and has dedicated a significant portion of the landscape to become them.
Okay, thanks, James. For the next question, I think this one is specifically about one of Maria's slides. It was they were asking why there were widely divergent estimates of forest loss in Vermont per year. So I think you had multiple numbers on that slide and for that.
Yeah, I was trying to mute, and then also I can scroll back to that slide if it's helpful, but it might be more distracting than anything at this point. My understanding, and I can have other people chime in as well, it largely relates to what is the time period during which its methodology. And so what is the time period that was used for a particular study? Sometimes, you know, it's in the 20 aughts, and sometimes it's in the tens. And then also the methodology in terms of, is it using forest inventory and analysis data? Is it or some sort of measurement versus is it maybe remote sensing from satellites? And so that's why I actually provided multiple numbers. This came up in a stakeholder meeting, is just to acknowledge that the exact number is not, you know, is kind of debate, it depends on kind of the assumptions of the analysis. All of them point to relatively little change to a few thousand, maybe 2,000 acres, 0 to 2,000 acres, you know, per year. And it just depends on how the analysis is run.
Okay, thanks, Maria. Next question, would clear cutting to create young forests be considered a land use change, forest conversion, or deforestation, fragmentation, et cetera?
Yeah, so the way that both national level carbon stock accounting, as well as sort of from a forest ecology and silviculture perspective, is that if the land is retained in forest, it's forest, it's not considered deforestation. And I think that that's a really important point. And it's not, it's a place where people can really talk past each other, because, and that's why I don't use the word deforestation, is not to say that land use change is not a big deal. It's not to say that bad management doesn't happen in some places. And that, you know, we might not, or we may not like how a certain forest is managed or what a clear cut looks like. But is to really point out the difference in terms of how is the land being used. And if a forest is clear cut, there may be a silvicultural reason to do that in terms of maintaining a certain forest type that's reliant on that. It may be addressing a forest health issue. You know, a lot of times that's why we call them silvicultural clear cuts. But that land is retained in a forest use and in a natural habitat use, as opposed to a conversion to something like agriculture or a lawn, because that requires a lot more energy. You know, that's a change in land use that has to be reversed. So hopefully that helped clarify things. Todd can jump in if I muddled anything. But I think that's a really important point when you're having a conversation, is to be clear on whether you're talking about that land use change or whether you're talking about forest management is a big deal.
Okay, thanks. Next question. Are you doing anything to greatly increase the total amount of stored carbon in U.S. Forest Service controlled forests? If so, over what time scale? And I don't know if, you know, James can maybe correct me, but I know there are numbers out there, you know, how much timber harvest we have done on the Green Mountain National Forest. You know, looking at those numbers, it's roughly 10% over the last, you know, over a 20 to 30 year time period there. So yeah, I mean, so 90% of the land isn't, you know, being converted to being harvested for anything. So, and then, you know, as Maria course, described in her presentation, that, it's more complicated. Even when we are harvesting, it's not there's different levels, there's different reasons.
I guess one thing I'll say that, it's kind of asking, I can't speak for what the National Forest is doing. I'll let James talk about that. But in terms of at a national level, and especially with the Biden administration and the, focus on the new administration on addressing the climate crisis, I think there hasn't been a detail in terms of policy that's kind of been maybe trickled down to the agency, all the way through the agencies to the national forests yet, given the time it takes. But there are a number of actions already underway. A lot of them are supporting land conservation across public and private, across private lands to increase forest cover overall, like 30 by 30. There's a climate smart forestry and agriculture development, and that really is to focus on addressing climate change risks and ensuring forests are restored and healthy to be able to adapt to climate change and have those carbon benefits. And the USDA is developing a adaptation plan, and that the Forest Service will be as well. So I think some of that at a agency level is very rapidly, kind of things are coming down. And so it might be that, there's more direction in the next 6 months.
And just to add on to that, I know that the question was directed at National Forest, but just to add on that, states are also really taking a lead here on thinking about climate mitigation and how to address carbon on natural and working lands. And Vermont is certainly one of those states that is doing that as part of the U.S. Climate Alliance, and thinking about state managed lands, thinking about how to do that, incentivizing that on privately owned lands, of course, in Vermont and across the Northeast. The vast majority of forests are in private ownership. And so it's really kind of an approach that spans across, federal, state, and local and privately owned forests, really to address this. And so, there's been a lot of progress. There's been a lot of movement on that in the last few years, even before this current administration. Partly through the formation of the U.S. Climate Alliance.
So I think the only thing I might add to what you guys have already said, and to get specific to the question, was managing for storing more carbon would mean you have the projection of what that growth of that stand is going to do in terms of storing carbon. And so going above and beyond that hasn't, as far as I'm aware, been an objective of any of our treatments, but it's certainly something that's occurring, globally and in the United States. There's carbon markets where primarily private landowners are able to show that their management is increasing storage above some sort of baseline. And we haven't done that here. It's not something we've done on the Green Mountain National Forest. But another way to think of it could be, is the end state of the forest that we're managing for, just kind of as Maria showed on that slide, like putting the forest in a more resilient condition and thereby potentially storing more carbon. And it's a lot of the treatments we do are designed to enhance that kind of health or resilience, especially to some of the ongoing kind of insects or disease issues. And so while it's not necessarily part or like the primary objective to store more carbon, in the end, oftentimes I think you end up with a forest that might be potentially able to store more carbon over a longer term if it's in a more resilient condition. So maybe Todd or Maria, you could talk about that.
I agree. I want to add something on a little bit different direction. So I want to see what Todd wants to get in.
Sorry, go for it, Maria. I was just typing a response in the chat box to a question directed at me. So
Okay. Well, I think so. Yeah. To James' points is, I think it's this idea of so I recognize, I mean, it's really great to be able to talk really honestly about the impacts of climate change and the climate crisis with these conversations. It's, you know, I've been working with NIACS for almost 15 years. And when I started, it was very hard to have these conversations at all because a lot of organizations and landowners and even members of the public were, you know, not interested or not comfortable talking about it. So I actually really do appreciate the conversation because you guys are participating at such a high level and you really do care. And I think, so to add on to James's point is yes, I think part of it is not that we're trying to figure out how do we ensure that if we're maintaining these forests and we're maintaining the carbon, that we're doing it in the places where it has the best chance of success. That we're doing it in a way that really does promote multiple benefits and in a way that enables the forest to have the capacity to adapt to a range of future conditions because we don't know exactly what's going to happen. I mean, that's like the definition of climate change is that it's unprecedented. And so there's a certain amount of thinking about, you know, where can we identify stands that we can point to particular stressors, to particular impacts and climate threats, other factors that might be inhibiting the ability of the forests to adaptively respond. And those are really honest conversations that we have when we're developing these projects with the foresters. And we do this for the other resource areas as well. How does climate change affect recreational trails and use, water quality, road crossings? You know, we really do think about all of these different resource areas and how they're vulnerable to climate change when we develop these projects. I think to go one step further is I'm looking at some of the comments and, you know, people are asking, you know, but shouldn't we be just stopping harvest to address the climate crisis because we need to stop putting emissions into the atmosphere? And I think that this is it's a genuine question. I think it is a really important conversation to have. One thing that Todd said earlier is that, you know, when we talk about climate change, it's what the atmosphere sees. And I think one caution to put out there, and I couldn't figure out how to put it in my talk because it's really important, but it's a subtlety, is there's a concept related to leakage. It's that if we stopped cutting on some forest lands, there would be leakage to other forest lands because the demand for forest products is not necessarily changing. And so we may be able to change, you know, like if we were to manipulate the supply and just, you know, for purposes of illustration said, Vermont is not going to cut any more forests. Let's, you know, hypothetical. Vermont is just not going to cut trees. I live in Upper Michigan. We have very similar forest types. We produce very similar products. I just think that that would get moved over here, or it would get moved from one land ownership to another land ownership. And so I think we have to be really cautious in terms of some of those trade-offs as well, in terms of recognizing that when we're talking about climate change, we really do need to be thinking about sort of these broader scale market and societal impacts as well. And that's a hard thing to put in there, but I did want to address that because I feel for the question. I understand it, but I think it's a more complicated system.
yeah, and that's an excellent point, Maria. And just to add just a little bit more complexity to those considerations, you know, again, it all comes down to what the net impacts are on the atmosphere, what the atmosphere sees, and we need to be thinking holistically. I'm a forest ecologist, right? So I get my blinders on thinking about carbon and forest, but when we have these really broad discussions, about carbon, it's really important to kind of step back and look at the whole system. Wood products are a part of that, and that very important issue of leakage. And another point of that is also what is known as substitution effects. And so again, if we were to imagine a hypothetical where we decided, well, we're not going to do any harvesting in our forests, and that impacts the supply of wood for lumber for building houses. What are our alternatives for how do we build houses? Well, it's much more energy intensive and fossil fuel emissions intensive building products such as concrete and steel that emit many times more CO2 into the atmosphere than wood does. And so again, if we were to just say we're not going to harvest wood and we're not going to allow leakage to occur, we're not going to allow, say, Canada to up its production of lumber, then we would be looking at a future where we would be building a lot more of our infrastructure or our buildings and homes from things that emit far more CO2 to the atmosphere. And so that would have a greater impact on accelerating climate change. So that's an important thing to also consider here.
All right, thank you. All right, sort of move on to the next question. This, Maria I think was referring back to one of your slides, but it was just a measurement of carbon lost from logging activity include carbon emitted by transportation of the wood, biomass burning, and other emitting activities that are associated.
Yeah, there was another question related to that as well. So this is one of the challenging issues, is that how wood products, wood energy, how wood products and wood energy are counted towards carbon varies depending on different studies. And it can be something that sometimes you have to make assumptions about how much wood is being actually, I have a slide on this. Hey, I was thinking ahead because I knew that this was one of the things that people were likely to ask about. Let me see if I can find it here. Okay. Oh. Okay. So yeah, there's a lot of different pieces when I talk about this forest carbon cycle, and some studies will include harvested wood and wood energy, wood products, and some don't. And so I think this is one of those things where it's always like read the fine print on a study to see how they handle these things, because people will make very large and different assumptions in different studies about how these things happen. One of the questions I saw in the chat that came to me was about, when you go from live vegetation to harvested wood to wood products, like what proportion of the carbon makes it all the way into a wood product. And that's going to be really variable depending on, the tree species, the type of mill it goes to, and the product. And so I can't give a certain number, but each time it goes through that step, there's carbon that gets left in the forest in terms of the limbs, the branches, the non-merchantable part of the wood. There's emissions associated with the logging, there's emissions associated with the transport to the mill. At the mill, some of that gets lost. Some of that might get burned up to run the mill in terms of wood waste. And then, there's a portion that goes into wood product. And so there are different studies that will have different numbers. I don't want to say a certain one because it's going to be highly variable. Again, depending on what the wood product is and the mill. Likewise, Some studies will include things like the carbon associated with emissions from the logging equipment, which is, something that is part of the whole life cycle analysis or assessment. It's something worth considering. The challenges is any of these kind of life cycle assessments are incredibly complex and difficult to do. There are some really great studies that are very comprehensive, but they are few and far between. They are very high level research studies. And so it's not something that's feasible to do, on the scale of one of these integrated resource management projects, because we would literally need multiple PhD level scientists per project. And often you have to make assumptions about some of these things. And so if we were to try and do one of these studies, we would have to try to guess or make an assumption, a reasonable educated guess about what type of equipment was used, how many hours would it be running, what is the fuel efficiency of the equipment, where might the wood go, what is the hauling distance to the mill, and so the uncertainties stack up very quickly. And so these studies can be really helpful for understanding how the systems work, but they are really challenging to implement. So there's some good ones out there, but I would need to kind of go into the repository to be able to provide any values.
Okay, thank you, Maria. All right, the next one's sort of a clarification. Do young, okay, when you were talking about sequestration between young forest and old forest, were you saying that young forest sequesters more carbon per year than an acre of old forest?
Generally, let me, I'm looking at Todd here. Like,
Yeah,
Todd,
generally on a per acre basis, young forests will typically sequester carbon at a faster rate than in an older forest. That's on a per acre basis. Very important to make that distinction, though. That's not on a per tree basis.
Yeah, and I wanted to just call attention to that as well, because I saw some comments related to that. And certainly, if you're thinking about a single large tree, even accumulating a smidge of carbon on the exterior is going to be a large amount of carbon per tree, but that tree takes up a lot of growing space. And so you might have one tree that takes up, the equivalent of 10 smaller trees in terms of space. And so we have to, when we're thinking about carbon, as Todd said, thinking about it on a per acre basis rather than a per tree. And that's not, I can see why that's not the way that most people's brains probably work. Just be happy we're doing it in acres and not metric.
Okay, thank you. All right, the next question is pretty specific, I think, for Maria, because it was part of her presentation. So I kind of paraphrase this correctly. So you had a slide with the label that said Forest Carbon Vermont, where Kosiba et al. 2021 was cited. Could Maria please explain to the audience why carbon lost from forest harvest is not displayed? I only see carbon loss from forest conversion or deforestation.
Yes, let me get back to that slide. Again, that was because in that particular part of the presentation, I was, let me get there. In that particular part of the presentation, I was really focusing on this concept of land use change and avoided deforestation. And then another part of that is that, sorry, let me get to that slide. And then, another part of that is that a lot of times when you're providing these state level numbers that are really high sort of level, the data is not necessarily available. Here, the data is not available to parse out the difference of different forest techniques. This is, essentially, this is generally will be based on something like forest inventory data or remote sensing. And so it's going out and saying, looking at, either physically or with remote sensing through satellites and imagery, is it forest or is it not forest? There isn't availability to actually understand like what is happening within how that particular forest is being managed. That sort of data requires a lot more information. Sometimes it's available, based on inventory data for a particular land management organization, but it depends because it's very costly to have information about how the different forest management activities alter carbon. And that gets back to the analysis point I mentioned earlier.
Okay, thanks. Sorry, I'm scrolling down a little bit here. Looks like I'm getting to some that looks like pretty much pretty similar to some questions we've already covered. So.
Yeah, I think I covered a lot that came in. There were some that came into me though. That
a lot of new ones too. So.
Mm-hmm.
Would it be valuable to give kind of a preview of the field trip, Todd? In terms of like what kind of conversations we might be having in the woods?
Sure. Yeah, we certainly can do that.
Yeah, why don't you go ahead and do that and I'll sort of try to, so we're getting down to the last 8 minutes here. So if you want to go ahead and do that, and then if I'll try to pick out a couple of maybe questions we haven't discussed yet.
James, do you want me to just kind of give a broad overview? Do you want to give a quick description of maybe some of the sites that we might be going to, and I can kind of follow in on some things that we can be discussing?
Yeah. So for those who were able to come to our last field trip focused on timber and ecology and engineering, we didn't visit the Telephone Gap project area for that. We went and looked at older projects, but for this one, this Saturday, we're going to be visiting the actual Telephone Gap project area, or at least a portion of it, for the area you guys may be familiar with out the River Road, which is Forest Road 57. And so we're going to visit kind of a variety of stand ages and stages of development, kind of similar to what Maria mentioned earlier, from everything from a wildlife opening through kind of early forests, in the 20 to 50-year-old range on up through some of our older forests in the landscape. And so there's along the way, we're going to be talking about that kind of difference between storage and sequestration, and also vulnerability and resilience to climate change. So we'll be meeting at that 3 Middle Road in Pittsford, Vermont, which is a kind of a large park and ride area, and then we'll be caravanning up the road to a main central parking area, and then kind of walking to all the sites. So unlike that last field trip, I heard you guys loud and clear you wanted to walk rather than drive to different sites, and so we've planned our day around that.
Yeah, so it's one thing to look at graphs and figures and cartoon diagrams of forests and kind of talk about some of these concepts of storage, sequestration, vulnerability to climate impacts, all these things, but it's a whole nother thing to actually get out in the woods and see it in person. And so, this is a fantastic opportunity for us to do that, especially on what is shaping up to be probably a beautiful day, beautiful fall day. And so, yeah, we'll have the opportunity to see different stands and different stages of development, different species composition, areas that have different forest health issues that impact the ability of those trees to continue to sequester carbon into the future, or to hold on to that carbon. So we could talk about and look at examples of areas where these issues are occurring, and we can kind of discuss, what are some of the options. What would happen if we didn't do anything here? If we just let this stand, sort of be unmanaged? What would happen if we took an active management approach to improve forest health? How are different stands that were treated similarly in the past, how do they look different based on the soils on the site and the kind of the site index? So we can look at examples in the real world. We can talk about them. We can talk about what some of the climate change projections look like for tree species habitat suitability in the future, to kind of start to think about, like, peering into the future to look at or to understand, what the potential might be to get to some of these desired conditions that we're talking about with this project. So really fantastic opportunity to continue the conversation that we're having. Ask a lot. I know there's so many more questions than we've been able to get to. I'm looking at my chat and I can't keep up with them all. So, this will be another opportunity to ask more questions and get more into the details.
Okay, thanks, Todd and James. Hopefully real quick, we'll get through a couple more here. So Maria said that as trees age, they absorb carbon more slowly, and she responded to the 2014 study published in Nature titled "Rate of Tree Carbon Accumulation Increases Continuously with Tree Size," that found that large old trees do not act simply as senescent carbon reservoirs, but actively fix large amounts of carbon compared to smaller trees.
Yes,
So
I think Todd and I have hit on this already. But I mean, the idea is, again, I think there is a really great questioning line of research being done on understanding the dynamics of these carbon sequestration of large trees. They do continue to sequester carbon because they're large. It is a large amount per tree. But when we look at it per acre, then the numbers are, can still be net sequestration, but it may not be as large because you have one tree taking up a lot of growing space rather than several small trees that might not be sequestering as much, but there are more of them. And so it's really a measure of it's really a way of how you're measuring the carbon, whether it's per tree or per acre. We use per acre because it's more apples to apples. And again, that's just on a carbon perspective, and it's not talking about the other values associated with large versus small trees.
Okay, thanks.
Yeah, go ahead.
Go ahead. Yeah. I think we have time for one more here. Like Todd mentioned too, I have 51 new messages since I started going through the first questions, so we have a lot we won't get to tonight. So Maria talked about trees dying from climate change in Vermont in the future. Could she explain how those trees might die? And is she taking into account that when a tree dies, it's left in the forest, the vast majority of carbon remains in the tree, only to very slowly release over decades, with much of the rest of the carbon remaining in the soil?
Yeah, great. I'm glad you got that one, because there was also a comment about me talking about trees mysteriously dying and how would that be? And so I think it depends. If we're talking about a single tree death or mortality, something like emerald ash borer, and we let those trees grow, yeah, they're going to naturally die, fall over, become, the emissions will be relatively slow over time, because it's going from live tree to standing dead tree to dead wood to forest soil. So that makes sense. But two other things is, we could have the potential for more catastrophic disturbances. Obviously, fire is less common in New England, but there may be other impacts, or if we had large forest pest outbreaks or wind throw, that could set up conditions for fire. So there could be pulses of events. And I think the last thing that I didn't get a chance to really talk about, but a lot of it is really focused on forest regeneration. And so many of the stressors that we're anticipating seeing, whether it's drought, invasive species, maybe changes in deer population, like there are so many factors that affect the ability of forests to regenerate. So a lot of those lags that we see in the model results are that the current trees that are on site, you know, will continue to do fine because they're established, they have some inherent resilience. But what happens is if we don't create conditions or ensure the regeneration of an understory or forest regeneration, we can be setting ourselves up for failure because there's no young cohort to move into those mid-story and overstory stages. So that's love to talk about that more, but that's kind of what's happening a lot of times in those models is we're hitting some sort of regeneration failure because of drought, extreme heat, species tolerances that are exceeded because of extreme conditions in the future.
Yeah, and just to say that, you know, this what Maria just described isn't necessarily just a like this could happen sometime in the future. I just moved to New England recently, but previously where I lived in Indiana, we had forests right in my backyard practically, where we had a lot of ash trees and we had a lot of invasive species like buckthorn and honeysuckle that prevented regeneration. And then emerald ash borer came through and killed all those ash trees. And the forest is largely gone. And what we have is just large expanses of invasive brush and not much else. And so it is a reality in places when you have kind of these multiple stressors interacting with one another. And it's certainly a possibility that could happen elsewhere. So it isn't just a hypothetical in some places. This I have seen it happen. So.
All right, thank you. So with that, I do have us being a little bit over our time today. So I'm gonna go ahead and respect everyone's time. And I would really like to thank Maria for her time tonight, and Todd, and also Maddie Baroli, who I forgot to mention at the beginning, who's been sort of in the background, sort of running the show here. Yeah, and James and Chris too. And thanks for everyone for all your questions. There are a lot that we weren't able to get to. So I will try to compile those. If you're familiar with our past virtual meetings, we have posted a link to a recording on the project website, along with the chat, and we've tried to answer as many of the unanswered questions that we weren't able to get to in the meeting in those documents. So we'll attempt to do that and to the best of our ability. And yeah, look forward to seeing people at the field trip Saturday. And I don't know if Chris or anyone, Maria, wants to have any final thoughts, but yeah, that was great. Thank you for taking time out of your evening to help us out here on the Green Mountain.
I just want to thank everybody for attending tonight, and we'll do our best to get the answers to your questions that went unanswered in the chat tonight. As Sean said, get that posted on the project website, but we really appreciate your time tonight, and we're looking forward to Saturday. Everyone have a good evening. Thank you, Maria. Thank you, Todd.